Yeah, you sound better now.
Oh,
So,
perfect.
yeah.
Great.
Yeah.
Did you you did already import the latest slides from Google?
I imported the slides as of like 3 minutes ago.
Oh,
and I'm
perfect.
glad that Meetico is picking them up so quickly.
That's great.
Yeah. So of course, the first question, as always, is do we have anybody who would like to volunteer to take notes? Ideally, somebody who's not presenting. I'll give a few more minutes for people to show up. I wish the Meetico participant list was clearer about who's really here and who's just logged into Zulip. All right, so I guess we can get started. This is the AVTCORE Working Group Virtual Interim. Welcome, everybody. I am Jonathan Lennox. My co-chair is Marius Kleidl. As usual, the virtual remote meeting tips. Raise your hand if you want to speak. That's the button on the bottom. I think they've changed the direction of the slash since we made these slides, but okay. You have to unmute to be heard. You can also unvideo mute, but that's separate. You may video mute if you want, but if you want to be heard, you also have to audio mute. Keep your audio off unless you're speaking, sharing or presenting, or speaking at the mic, obviously. And use a headset is recommended because sometimes the echo cancellation isn't perfect. Note while applies, this is an IETF meeting. By participating, you agree to follow the IETF procedures, processes, and policies, particularly in regards to patent rights. We will be recording this, or we are recording this session, and we have a code of conduct. So if you're starting a presentation, you must say if there's IPR associated with your draft, and when commenting on it, you must disclose it if you control it, and there are potential sanctions available, and see the various RFCs for details. Also, as mentioned, we have a code of conduct, so please treat everybody with dignity, decency, and respect. Do not engage in any harassment of any kind. If you've noticed any problems with this, please talk to the ombudspersons. And we'll continue to remember Bernard Aboba, our former co-chair who died in February. So meeting, we particularly, as always, as point of the call, we need a note taker. So if somebody would like to volunteer to take notes, or more than one person, if you're presenting, you could take notes for the parts you're not presenting, and then have somebody else take over for the other parts. But we cannot move forward without a note taker. Anyone, please. Who's here who's not presenting? Okay. I'll let you know who's here who is presenting, but wants to take notes for the parts that they're not presenting, and we have somebody else take over for the part where they are.
If nobody volunteers, I can also take
All right,
the most important decisions.
All right, I guess we'll have to do that. All right, well, thank you. Okay, so agenda. We have SDP offer answer for RTP over quick. We have S-frame. We have VDMC. We have JPEG XS. We have green metadata and volumetric media region of interest. And do you have any comments or requests or changes on that? Otherwise, we will get started. Sorry, first, we're not going to quite get started. So yeah, we've got a number of RFCs published, so that's very exciting. J2K SCL is going through, went through IESG review, so it's been approved, so that's exciting. If you follow the GitHub, there were a bunch of stuff going on in the GitHub because the authors tracked every comment from last call as a separate GitHub issue, which is a very good practice. I recommend it to anybody who's doing the last call. And we've got a few things and working with last call, green metadata, we have some discussion of in a bit. Okay, draft status, a number of things adopted. For HVC, Philip Hankey has agreed to take over as the editor. He was previously the co-author on that. Bernard, of course, was the editor on that, and so we needed somebody new. And S-frame is parked, but we're discussing it today, so it will be hopefully unparked. So SDP, Spencer, do you want me to hand you slide control? Or do you want me to drive?
I can do slide control if that's okay.
Sure. Yeah, let's see. There we go.
Okay, perfect. Thank you. So this is just an update on SDP offer answer for quick over RTP on work that's happened since IETF 122. Just for coordinates, this is now in the GitHub repository for AVTCORE, which means it's included in the weekly GitHub activity summaries. We've recently updated the main branch based on private review from Harold, plus discussions at IETF 122 AVTCORE meeting, and then some general cleanup of the AVTCORE repository issues, and there is still more work to do. The changes to the main branch so far, resolving a bunch of suggestions from Harold, thank you. Some were editorial changes throughout the document, corrected the proto descriptions in section 3, moved the ABP related security considerations up into the body of the document so that it's someplace where people will know to look for it, and removed section 1.2, which was basically questions for the working group. We're now doing a better job of tracking issues in GitHub. And that gets me to the next slide. have a couple of issues that I would like to have working group input, and here at this meeting is fine with me, but GitHub also works. The first is that, and these are issue numbers. Issue number 22 is that we've talked about removing the quick datagrams advisory indication that's in SDP. That doesn't actually control whether datagrams are negotiated. That happens during quick initial handshake, and it doesn't control whether datagrams are used. We've had people who commented that said implementations might benefit knowing that a peer ROC endpoint intends to use datagrams, but it's not clear that this advisory indication is helpful, because if you don't negotiate quick datagram support at the connection handshake time, you're not going to be using them anyway. My inclination at this point is to drop SDP quick datagrams as just one potential inconsistency that we can avoid. Does anyone have strong feelings about that? And if so, would anybody like to say something nice about why we need to keep it? Jonathan?
Yeah, so my inclination, speaking as an individual, not as chair, of course, is that if we don't understand what the use case is for having it, and it's purely informative, so adding it later wouldn't cause compatibility issues, let's drop it. And if somebody comes up with a use case for it later, it can be added either later in the development of this, if it's early enough, or as an extension later. There's no backward compatibility issue with adding it later if it's purely advisory anyway. So I'd say drop it for now if we don't understand the use case, and if we do have a use case in the future, we can re-add it.
So as I mentioned on a previous slide, this stuff is being, so that is a GitHub issue number 22 that people can comment on, and the activity where that goes away will show up on the working group mailing lists in some form also. So please feel free to express opinions, but that's the first thing I'm going to do. The second thing that we're going to do, or that I wanted to hear from the working group about, is, and this is thank you, Harold, for poking on this. The draft sort of kind of assumed that people would be doing 5761 style RTP, RTCP multiplexing, but we never actually said that. That works fine in ROC with putting RTP and RTCP on one ROC flow ID. If we don't require that, then we'll have RTP and RTCP on different ROC flow IDs. So we need to be able to associate the RTCP with the corresponding RTP in SDP. Again, I'm curious about what people in the working group think about that. And I'm really kind of asking, is anybody desperate to use ROC without using RC 5761 style multiplexing? I should wait for people to walk to a microphone. Harold?
Just saying that we have in WebRTC, they actually ended up saying that we should not need to support non-multiplex flows. That it's a hassle to have both options, and if the spec says that you have to do 5761 multiplexing, then I'm happy.
Thank you, Harold. just for perspective, I think that at least I started out thinking about RTP over quick as if you would take any random application that was using RTP and change, and adapt it so that it would run over quick. But I think we're getting far enough down the path to say that anybody who is willing to modify their applications to use ROC, if they're not using RTP, RTCP multiplexing now, that shouldn't be a huge change. So my inclination with that is that we'll go ahead and require the use of multiplexing. So I have two upcoming work items that we're focused on. One is from Harold, echoed by Jonathan, and some conversations we'd had with Sam Hurst in the past also. And then one from Harold on using needing to clarify how to use ICE with ROC. And again, those are the issue numbers. So paraphrasing Jonathan, because his summary was very, very helpful. Bundle multiplexes multiple media descriptions onto a transport connection. Flow ID multiplexes multiple media descriptions onto a quick transport connection. How do these work together, if at all? So I spent a little time talking with the co-author, Metis, the co-author on ROC. And we said, well, the top arrangement has worked for a while with bundle. The middle arrangement works. That's what Metis has been doing interop testing with. And so as best I can tell, this down boy. As best I can tell, the right way to arrange this is to say that a bundle would be bundling ROC flow IDs, basically, each one of which would be carrying a media flow. Jonathan requested that we include a bundled example, and let me close the door. Pardon me, they're not on me to echo. And that sounded like a excellent plan to me. The one question I've really got is, do we really need to worry about this? Do people who use bundle now and need to think about ROC flow IDs in order to use ROC, do they need to use both of them? I suspect if the answer is yes, it will be because we need to support middle boxes that are middle boxes between ROC endpoints and non-ROC RTP endpoints. Jonathan?
Yeah, and this touches a little bit on the previous point about the RTCP. So I think bundle and to a lesser extent RTCP multiplexing were both sacrifices of practicality of the original RTP architecture for the sake of making middle box passing easier. And those issues obviously don't apply if it's all on a single quick connection, because you don't, all the quick handles all the transport multiplexing.
Right.
And so in theory, you could keep the things that should architecturally be separate, so you don't have to worry about things like, I know that when we were doing bundle, people were worried about, well, hey, the natural RTP feedback time for video wants to be actually significantly faster than what audio wants, things like that. So this, allowing this would maybe allow some of the, initial architectural properties of RTP to come back. On the other hand, maybe nobody cares about that because we've all adapted to these architectural concessions anyway, and it's been fine. Nobody's really feeling pain from not having these, nice properties that were designed in, but I'm not sure how important they actually were. So, and certainly it will be, the code will be more complicated, especially if you're starting from existing code bases that assume a single RTP session. So I'm sort of, I think that's the reason I looked at this, because I was thinking about the initial RTP architecture, but but I'm not a purist about it if nobody actually cares about it. So
yeah, we were definitely just trying to be complete. Thank you for the comment, Harold.
Yeah, both for this and the previous thing. The thing that's irritating about them is that they affect other things. For instance, if you bundle, then you have a lot of restrictions on things like header extension numbers. You have all these things that are identical by PT or identical or special in the bundled RFC. So I'm halfway inclined to say that that not bundling was a stupid mistake in the RTP design, and we should require that everything's bundled all the time. And the other half is that I think that bundle was a patch that was required because we were saving port numbers. It was not due to middle boxes, and we were saving port numbers, and that we should just say that that bundle should never be used with ROC. Of course, if we never use it, then we place a burden on gateways to strip it out, and
yes, exactly. Yes,
and especially we place a burden on gateways to renumber everything that needs to be renumbered in the other direction when we have to fit within the bundle framework. So looking at it from a gateway standpoint, I'm kind of 51% in favor of requiring bundle always, and 49% in favor of banning bundle forever. But I'm 100% not in favor of letting people choose whether to use bundle or not.
So yeah, so it's necessary to make a decision, and it would be good if it was the right decision.
Yeah. Yes.
Perfect. That sounds very much like what I was expecting to hear. What I was hoping to hear. Thank you for the continued comments. Anything else on this slide? So, and this was from Harold in a private email, and I've been thinking about this for a bit. So this was Harold's comment, and I think the most important thing that jumped out to me is the part that's in yellow, that there's not a mechanism defined to supply or to specify ROC as an ICE candidate the same way a TCP or UDP candidate can be specified. And this has implications for the proto field. I think that I'm kind of starting to ask the question, do we need to make ROC a first-class RTP transport like UDP and TCP SCTP and DCCP, but I'm still catching up on this one. But we did have the working group meeting, so I wanted to give people a chance to share thoughts. Jonathan?
Yeah, my inclination would be to say no, and I mean, rock should not be a ice candidate. I think that, depending on how we decide to run rock over ice, you'd have to figure that out. But I don't think you should be able to negotiate whether you're using rock or whether you're
Okay,
using RTP
yeah.
over TCP, or RTP over UDP. Just like you don't negotiate whether you're using ice or not ice. You kind of do, but you shouldn't. So I would say, you make an offer with rock, and if the other side doesn't like it, they can reject the M line. But I don't think you should be able to negotiate whether it's rock or not rock. That sounds way too complicated.
Okay, and thank you for that thought. It's very helpful as far as steering me on which direction I'm going as I'm writing text. Harold?
Just to make your life more difficult, I kind of think the other way, that rock should be it doesn't make sense to make rock a second-class transport, whatever that means. So if it's a transport that RTP can use, then it should be a transport. And if we want to be able to choose between transports, like you want to interoperate with endpoints that support rock, and you want to interoperate with transports that don't, and you don't know when you send the SDP offer which one it is, then I think making it a first-class transport that can be chosen as an ICE candidate makes sense if we support ICE with rock.
Thank you for the comment.
I think we'd need to at least see somebody have some brainstorming of what that would look like, because my fear is that it would look extraordinarily complicated, because you're simultaneously making the path decision that ICE does and the protocol decision that of quick versus raw UDP or whatever.
Right.
That sounds. I'd want to at least see a straw man of what that would look like, before we can say yes, this is something that's practical for us to engineer and practical for people to implement. Because that sounds. I mean, I agree. It'd be nice to have the ability to do an offer that, works with backward compatibility, but it feels quite complicated.
So I think if I'm understanding where we are right now, Harold's first point on is the ice inside rock or outside ice. That's like the first conversation we need to have, and then we can go from there.
Yeah. So maybe we should have a side meeting about this in Madrid. That feels like something that could use some napkin work.
Excellent.
Yeah,
okay.
Pull in some of the other people who are interested in peer-to-peer quick also, maybe.
Cool. So planning to resolve the issues we discussed at this meeting, planning to propose text based on the rock flow ID bundle discussion at this meeting, proposed text based on ice with rock discussion. That may be quite a bit more preliminary. Submit a 01 before IETF 123. I'd asked for early reviewers, and we worked with Harold and a little bit with Jonathan. Gertag volunteered at the last IETF to be an early reviewer, and that's about the time that I would be hoping for more feedback from Jonathan and feedback from Gertag. Hoping to request adoption sometime around IETF 123, but that's kind of what I know about SDP for rock. Anything else?
Yeah, so I have a bit more of a general question about this, and especially the relation to the rock draft itself.
Right.
At the last IETF, the authors of rock basically said, okay, we're done with this for now. We're considering, or we should do a last call on rock itself. And what I recall was that we said, okay, let's wait where the SDP work goes and see if there's any changes regarding that need to be made in rock in order to make SDP work. And I'm wondering if this is still true, or if this has progressed so far that we can now safely say, okay, let's do a last call for rock and move forward there. How do you feel about this? And maybe even, I think Mattis is also here. Maybe he can
Yes.
also voice an opinion on if that's true, or if we can move forward with a last call for rock.
I should let Mattis answer first, but I do have a thought.
Hi.
Mattis, you.
Yeah, hi. So I think we said so from our perspective, last time we already said that we can move forward without waiting for SDP. At least in the process within the working group, like having a working group last call, because I think that would maybe prompt more feedback on the rock draft itself, because we haven't gotten any feedback on that in the last couple of months. And I think even if there would be any changes that we need to do based on the SDP stuff that can happen, can still happen, I guess. So we don't really think there's a strict dependency on these, but just in case, I think this can still happen later.
Right.
Because like right now, the rock draft is kind of stalled and nothing is happening. And I think we could make more progress if we don't wait for SDP.
So that's certainly strongly possible. The other thing I should mention is we're targeting experimental for rock, right? So if we were trying to go directly to proposed standard, then maintaining perfect backward compatibility with every version of rock that we ever publish would be something that would matter. But that's not really a criteria for experimental. I think that from my perspective in conversations with Mattis, who I believe I'm quoting correctly, we were talking about what's the relationship between flow ID and bundle. And unless we thought we were going to say, oh, we're not going to do flow IDs anymore, we're going to somehow require bundle and use bundle IDs for multiplexing. That would be an example of something that would affect the base rock spec, but that's not where we seem to be headed. That's not where we are, and that's not where we seem to be headed. So I think that the chances of us coming up with something that affects the base rock specification, I think that's going down every time we have a meeting.
Okay, perfect. That's really helpful. So what I'm hearing is that we can move forward with rock for now.
I think so.
If there really comes up necessary changes that we can't work around, then there will still be possibilities in the future to address them in rock. And then as Mattis said, we can make sure that rock doesn't stall and that goes ahead.
I'm an author on both of them, so I'm the stuckee at some level. Srinivas, are you in queue for this also?
Yeah, thank you, Spencer. I just have one question. So the rock flow ID, I see it as like an SDP level attribute rather than a media level attribute in the current text. So I understand like you're also considering about the bundle, but is it possible to allocate like two different media or rock flow identifiers for different media streams. For example, like if I wanted to bundle a video and audio in one rock stream and media stream or flow ID, and another audio and some other media into a different rock flow ID.
So I believe that, and we had a slide about this. Which one was it? Thinking in terms of the middle line here, that you can put multiple media flow, multiple rock IDs. Sorry, you can have multiple rock flow IDs on a single quick connection, and each one of those would correspond to a media flow. So if you had 3 media flows, you could have they would have 3 different rock flow IDs, but they could all be in one quick connection. Is that responsive?
Yeah, but how do you identify? So you put this rock flow ID in each media M equal to something in each media section, right? The attribute.
I believe that's correct. I should be checking very quickly, but I believe that's correct.
Yeah, because in the example SDP in section probably 6, yeah, because part of the audio, there are 2 audio streams and 1 video stream, but there is only 1 rock flow ID. So I assume that all 3 will use the rock flow ID 2 there. But if I have the option to choose different flow IDs, then I will put like a rock flow ID 1 or 3, something else in the corresponding M equal to section, right? Media section.
Right, because the rock flow idea is really just to be able to do the just to do that multiplexing. So yeah.
Okay, thank you.
Thank you. And I think I have an opportunity to make something clearer in the specification.
Hopefully, thank you.
And I think I can hand back to the chairs.
All right. Thank you, Spencer.
Thank you so much.
All right. And let's see. All right. So, Richard, are you presenting?
Yeah, I think I'm stuck here for this.
Okay. Do you want slides control? Or do you want me to drive?
Can you just pass that over in MeetEcho?
Yes, I can.
Sure. Yeah, I'll do that if it's that easy.
Yep. You
and I
should have it now.
apologize. I will be invisible for this because MeetEcho is not cooperating with Firefox nightly. So those of you who've been around for a while might recall this draft has been around for a little while. It went quiescent, got parked at the last IETF meeting, and then folks took interest again. So this is basically our reboot presentation. So we're going to start from the very top and then get to a proposed new direction that a few of us have been talking about for the document. So the very top level background here is we had this whole working group defining an encapsulation for stuff. Basically, the idea is this S-frame is this lightweight encapsulation for symmetric encryption of really any data, but the way we want to use it is for encrypting media data. It adds a little header with a key ID and counter, and adds an overhead, which is initially an auth tag. So we'll be kind of trying to use these same visual cues throughout here to help make some things more understandable. The reason the need for this comes up is this WebRTC encoded transform spec. Those of you who've dealt with WebRTC will remember that it typically keeps media isolated from JavaScript and doesn't let JavaScript interfere with it. You have media as it's encoded and then packetized and sent out and vice versa. There's some recent changes that allow JavaScript to get various types of handles to that. So this script transform hands frames out to JavaScript after they're encoded and before they're packetized, so that JavaScript can do things like add this extra layer of S-frame based end-to-end encryption. There's also some work on this S-frame transform, which does this same style of encryption, but without having to hand the packet out to JavaScript. So you still get the nice isolation benefits that you get from the base WebRTC spec in terms of minimizing JavaScript's access to media. The JavaScript just passes in keys, and then the media, the WebRTC stack does the encryption. So with this context, the goal of the document here in AVTCORE is to define what the SDP and RTP is that WebRTC should emit and consume for these cases. And we say apply S-frame here. There's a couple of cases we'll talk about here, one of which is applying it per payload, which is what we've deployed, for example, in WebEx. There's some benefits to that and some drawbacks. And the other approach here is to apply it per frame, which is compatible with the script transform and is what has been deployed in some other products. So one of the interesting challenges here is how to accommodate both of those approaches, because they're applicable to different use cases. Yeah, so with that in mind, our overall requirements here are to update, enable RTP endpoints to transmit and receive media that has this extra layer of S-frame based encryption. And we want to allow both of these modes, the per packet mode, the per frame mode. Per packet mode has higher overhead, but you get basic access to RTP. You get access to the same RTP payload level, which means you can do things like subframe decoding and pipelining. The per frame mode obviously amortizes the overhead from the encryption over more packets, but you have to wait till the whole frame shows up to decrypt it and use it. So there's kind of those trade-offs. Obviously, if you look at those costs, those trade-offs, different applications might have different preferences, and so our goal here is to accommodate both. The other requirement we have here is to facilitate migration from this generic RTC script transform to the S-frame transform, where the browser's doing stuff. So if we create a standard way to do S-frame with these few modes in WebRTC, it would be good to let applications who are now using the script transform to do frame-based S-frame encryption eventually give them a path to migrate over to this S-frame transform. And what that kind of comes down to is either wire compatibility with whatever RTP is emitted by the script transform stuff, or punting the question of the application layer and saying just negotiate both and then switch it to an application layer thing. And of course, this is designed to be as an encryption thing. It really doesn't care about media. And so we're trying to be codec agnostic and just define this as a layer that adds some encryption, irrespective of what the media looks like. So where we are today, we clearly don't have an updated draft yet, but wanted to kind of sketch a proposal, sketch where our thinking is as the author team, and get working group feedback as prep for actually making a real document for consideration at the IETF. So the thinking right now is to, at the SDP layer, make this an M-level attribute. This is not something you need to have, some streams encrypted, some streams unencrypted. So let's just do it at the whole M level. And that attribute, just have a fairly opaque attribute to say, we're going to have S-frame encryption here. We're going to do it according to one of these two strategies. And maybe, and we'll discuss this a little later, maybe we indicate what Cypress suite we intend to use. And this is kind of coherent with that theory I was just talking about, that S-frame is just a layer in the processing stack, that it's the media stuff is going to do what the media stuff does, and all of those good smarts that relate to codecs and whatnot that this group does, it will all happen more or less as normal, and then this S-frame stuff will happen. We have these two modes, per frame, per packet. In the per packet case, it's a little simpler to describe in RTP terms. You just take whatever your normal payload type is, you wrap it in the S-frame wrapping, and you send it on. With per frame, it's a little different in that you will take the frame, the encoded frame, S-frame encrypt that thing, and then chop it into segments that become the RTP payloads. In pictures, I apologize. I think we have an earlier version of this, but we have a new version that has better words. I realize that bundle is a reserved word in this working group, so this is not actually bundles in the STP term, STP, or whatever other context you're thinking of. This is just like a list of payloads that comprise a frame or an LU or something. So this is kind of illustrating the different approaches we have in mind here. So normal kind of media stack processing on the left. You take a frame, you split it into chunks like now or the encoder emits these chunks. You pack those into payloads and you emit those as RTP packets. With per payload S frame, the only change here is that you introduce this extra layer where you take the payloads after they're assembled and you wrap those as S frame ciphertext, and then those things become the payloads of the RTP packets. So in that framework, you can kind of see how the RTP payload type directly translates through, because that's the content of the RTP packet is whatever the payload type was to start with, wrapped in S frame. So in terms of how we accomplish this amortizing over more data up to a frame, we had kind of two approaches. The one that's more compatible with the script transform is on the right. The script, the second step there, where you form a frame, is kind of where the script transform gets access. Now you would kind of chip that frame off to be manipulated, however, by JavaScript. You get the manipulated frame back, presumably encrypted. Here we presume it's encrypted, so the S frame, the thing that is S framed, is the whole frame, and so you amortize the overhead a bit more. And then you take that encrypted blob, which is obviously at this point you can't use media details. I can't look inside there to do packetization, and you split that thing into chunks that become your media payloads. So a couple of different, oh, I'm sorry, just to explain the middle one here, the bundle one. The idea there is to do the packing of these chunks into payloads according to the payload type, the same as you would normally. And then for your amortization, instead of considering a frame that is encoded as a frame using something like H.264 NXB or lock, your frame, your unit of encryption just becomes a bunch of RTP payloads that are just concatenated. So you remember where the cut points are, you concatenate them for encryption, and then you slice them again at exactly the cut points you had before. So the packet boundaries remain consistent, and so the content of these RTP packets is just the original payloads encrypted, and the first one in one of these segments gets the S frame header, the last one gets the tag, and otherwise it's just encrypted data. So there may be there's some overhead trade-offs between these the two approaches on the right-hand side of the slide, and there's some kind of trade-offs in terms of compatibility with the script transform that's being done today. So that's kind of the universe of approaches we have in mind. Yeah, again, opinions welcome about what seems appealing here. Just to talk briefly about this generic packetization, this is needed for I think either of the approaches where you're fragmenting an encrypted thing. The depacketization stage needs to be able to reassemble the encrypted thing that you fragmented to put into RTP payloads. When we say fragment header here, that just basically just means an identifier for the unit and a number of payloads and which payload you are in there. So there's sort of fields that I believe that's basically what's in the document right now. It's a little bit unclear whether we actually need this. If in a simple scenario where you don't have something like SVC, you might not actually need the fragment header information. You might just be able to use the marker bit and timestamp. And you might be able to just use a header extension in cases where you do have something like SVC. But that's just kind of gives people an idea for the packetization changes envisioned here. And yeah, so the proposed, what we're proposing to do in this document when we produce a new revision is to have kind of two payload formats, one for the opaque version, which is just an S frame ciphertext wrapping a payload type, and then some sort of fragmented one, which is a fragment of a bigger unit. So the an individual RTP payload is a segment of an S-frame ciphertext, and the data internal to the encrypted thing is determined by the payload type. Either that's some frame format corresponding to the payload type, or it's the payload types themselves, if we do that concatenation thing. And then at the STP layer, we just have this RTP attribute, this STP attribute that says we're doing S-frame, pretty opaque, and says this which scheme we're doing. So I think that's the last bit I had. 3 known open issues. Yuan and I talked this morning and edited the slides, but it didn't, apparently just didn't make it up into the data tracker after our edits. So I think a consensus among the author team after talking about it after these slides were posted was that we should probably not do cipher suite negotiation in SDP. There's some other, when you're doing cipher negotiation, you want things like downgrade protection, which SDP doesn't really provide, especially when you're doing it via potentially untrusted intermediary. So I think this is probably not something we should do here. We should just omit that cipher suite field that you saw in the previous slides and do it up a layer. Like I said, it's not a little unclear that we need the generic fragmentation header as part of the payload. So the proposal there is no as part of the payload. We may still need a header extension that lets you do this fragmentation indication in case of scalability or what's it called, layering. And then finally, the big question here is what modes, how should we do this? How address this situation where we're amortizing the S-frame over more than just a payload? Do we do this per frame approach, which has more compatibility with script transform? Should we do this bundling concatenation approach, which has slightly cleaner RTP semantics? Or should we do both? I think both is an option, but I think a lot of this has to do with what this working group, thinks in terms of compatibility and in terms of compatibility, compatibility with the script transform and existing web code versus compatibility with kind of RTP semantics. So that's all I have. Feedback, welcome, and we'll work on a document for the Madrid IETF. Jonathan.
Yeah, so I agree on the cipher suite negotiation because obviously something needs to negotiate the keys, which isn't going to be an SDP. And I think if you're doing that, telling what the keys mean at the same place makes sense. I don't think.
Good point.
Yeah. So on the fragmentation header, my worry about marker bet plus sequence is knowing when you have the first packet of a frame, because if you don't want to be in the situation where if you lose the last packet of the previous frame, the only way you can know whether you've got the complete frame is trial decryption. So I think you need at least a start bit as well as an end bit, but I think that's all you need with sequence numbers. So possibly now, if you're assuming header extensions, which if you're doing this in any kind of SFU mode, you need something to tell the SFU things. There's no point in doing S-frame if you don't have an SFU. But so I think you need to, assume, something that gives the SFU all the information it needs, which probably has the start bit in it anyway. So, but you'll probably need to say that somewhere explicitly. And also this means that that SFU information does need to go end to end all the way down to the receiver, which probably solves a lot of other problems for you too. There's a lot of stuff in payload formats that tells the receiver how to handle things like packet loss, which I think the richer header extensions can do for you. But you do need them if you don't want to just assume you get all the packets or you stall, which is a thing you can do, but it's not great user experience. So yeah, I would say that my short answer is you do need a start head flag, but you don't necessarily. But that might be in the header extension, which you need anyway. So the other point I did want to make, at least is something I've observed in the current script transform case, which you want to make sure doesn't happen, and maybe you said this, but should be said more explicitly. This current script transform case doesn't actually work right now for H.264 or AV1, and the reason for that is because those packetizations look inside the payload to look for null units or the AV1 equivalent thereof, and if it's encrypted, that doesn't work. So you need to basically do some hacks to trick it into thinking there's one big null unit for it to successfully packetize the thing. So we want to make sure that we don't require that, and that and in particular that the stack knows, hey, this is an encryption. Don't try to look for null units. Just treat it as an opaque blob. And whether that means sending it as a payload type, that means this is an opaque blob that happens to have H264 inside it, is a separate question. But we do need to make sure that works.
Yeah, that kind of goes to the frame versus bundle approach, because the frame approach, for like, it throws away the media aware packetizer and just does, you know, like MTU based packetization. It doesn't say anything at all about the internals, which is it's okay in that case, because you can't do anything with the data anyway until you got the whole frame.
Yeah, which is like I said, that's fine as long as, I mean, right now the problem is that you're throwing away the at least in Chrome, in the Chrome RTC stack, it doesn't know it doesn't know that it shouldn't do the media aware packetization, and bad things happen. So, but that's something we can fix.
Maybe an implementation thing.
Yeah.
Speaking of Chrome, Harald.
So it's good to see that we have something about how to negotiate S-frame and SDP. And the bad thing is that I don't like the way that it's done. Because in Chrome, unfortunately, or in WebRTC, unfortunately, I would say, we implemented almost exactly this mechanism. Is called A equals packetization with a possible value of raw. One of the things that happened when we introduced that was that we effectively doubled the number of payload types for all the codecs that would support this raw packetization. Because RTP payload types are defined by their packetization, including their packetization. So internally, I argue that we should go back to treating these as new codecs. That is, you have a codec called packetized, and then you would negotiate support for the packetized, and then a parameter of that would be the inner type that would then be at the frame level. So I think of S-frame as a S-frame plus whatever coding goes into it as a codec. I mean, it's a combination of a media format and a packetizer and the packetizer just happens to encrypt in this case. So I don't like the A equals S-frame much. You can tell that I'm in favor of frames because that's what we've implemented before. But let's see that others have problems with that. I think I'll stop there and let other people speak.
So Harald, a quick follow-up on that. You know, clearly it would be nice to avoid, you know, a bunch of payload type duplication, which I think was one of the problems with the last round of this. Like, so is there a way to like make this an attribute on a payload type somehow, just to say that like the packetization for the other, as you know, this is a variant of this payload type that, you know, uses this different encrypting packetizer, something like that.
I would like to wrap it the other way around, because there's another issue here, which is with the actual payload type number that you're passing around. I think that's inside the encrypted payload, is it not?
No, the payload type is outside. It's in the RTP header, not the encrypted payload. So the payload type is not protected by S-frame.
So that's an unprotected attribute, and that means also that you have, when you negotiate a connection to an SFU, and that that SFU has a connection to the end user. If they negotiate different payload types for the inner codec on the two hubs, then that payload type has to be changed.
Well, right, and this is why having two codecs, two payload types seems not great. It would be better just to have one annotated codec that says this is H.264 with the S-frame additions.
Yeah, it's also possible that we should try to separate the concepts somewhat. I mean, one of the big issues here is the way H.264 was defined, where packetization according to H.264 requires quite deep knowledge of the frame format of H.264. There's no simple layer that you can intercept that. To say that I find this complicated. I mean, the thing I wanted to say is that we tried the packetization as attribute, and it has caused complexity. So S-frame as attribute causes the same kind of complexity, and I mean it multiplies the number of possible codecs that we have to negotiate by 2, almost no matter what you do. And you have to say that you have to make interpolation so that if I suggest S-frame and you reply that you don't want S-frame, well, you shouldn't get S-frame, and that's in violation of that kind of violates the idea of that you should be safe by ignoring A attributes that you don't understand. So I'm not happy with this one, but I don't have a good alternative proposal.
All right, Yuan?
Yeah, I wanted to ask to Harald if there's so you mentioned that this M section wide attribute should be optional somehow, and I was wondering whether there was already an attribute that if you drop it, then things are breaking.
What I said was that the SDP basic spec says that
Okay.
you can ignore any attribute you don't understand.
I see.
I didn't catch the point that it was session wide. I thought it was
It's M section wide. Yeah.
M section wide. I thought it was codec wide.
But yeah, I
No.
do kind of wonder whether that provision is held up in practice. I think of, for example, of A equals crypto, which, you can't ignore that.
Yep.
Well, then there the negotiation rules say that if you get back, well, luckily we have now failure when you say A equals crypto. Yeah, I mean that I can see, but and I think the rules say that if you ignore that in the reply, then you're not encrypted, and then you can decide whether you want to continue or not.
So maybe there's a path forward there.
Yeah, I mean, it seems like if this has been solved for A equals crypto, we can just copy paste whatever that solution is here.
If it's a solution. Yeah.
And so the other additional question I had to Harald. So you say that we're multiplying the payload types by 2, and the the goal for adding this end section wide attribute was to actually reduce that, like disable this two payload, one being encrypted and the other one being not encrypted. When we discussed that within the WebRTC working group, it was thought that for a given transceiver, there's no reason to allow a sender to send like encrypted or unencrypted content, and it was good to actually mandate that either it will be all encrypted or all so all S-frame or no S-frame at all. If we go down to the payload type fine-grained approach, like S-frame being like a codec, then we no longer have this guarantee, which seems nice. And we add some overhead, like we would need to add back the inner payload type to each packet, which is some overhead, but would be good to not have, in particular for HFUs, because then you have like different one payload type you change because you want to say that you are S-flame, and one inner payload type you want to change because you want to say you are H.264. So it seems like a good simplification if you can have it.
So I have some ideas, but I think we're over time, so we probably should move on. This seems like something that we need to also need a side meeting for. Who all this group is going to be in Madrid?
I am.
Okay.
I don't know, maybe. In any case, there's a GitHub repo.
But I think certainly some sort of a side meeting. Virtual would also work, but it's a side meeting for this would probably be a good idea. So we should probably schedule something.
Thank you.
Yeah. Okay. Yeah, but I think we probably need to move on because I think we're like 15 minutes over time.
But making it a transceiver attribute instead of a media attribute, that was an interesting one.
Yeah, but I mean, I have some ideas on how our A equals crypto actually works in practice, but we can discuss this offline. All right.
Well, thanks for the feedback, everyone.
Yep. All right. So I'm going to grab the slides back from you, and like, why did it go backwards? And move on to Hyunsuk. All right. Do you want the slides, Hyunsuk, or do you want me to drive them?
Could you control the slide, because I
will do that.
Yeah.
Sure.
Thank you. Can I start with the next slide? Hi. So today, let me start with a brief history of the draft for the VDMC. We submitted the initial version in October 2024, and since then, we have released several updates, version 1, 2, and 3, and we also received additional comment from the AVTCORE members. Thanks again, and as well as other company involved in the VDMC related works. And just weeks ago, we submitted our IPR declarations. Next slide, please. So this slides show the current status of the VDMC standard and its applications. So the reference MPEG paper, which is 29, is now at the FDIS balloting stage, which means it's close to maturity. And the many companies and even some university are actively participating in the VDMC specification effort. And we believe the VDMC is the key technology for the gaming or other AR, XR applications. So I think that this is a really good time to standardize work. And in fact, the 3GPP SA4 is considering including software for VDMC as part of future video format and the codec. So several organizations are already exploring the use case for VDMC over real-time protocol, including web browser-based VDMC transmissions. Next slide, please. So I believe that this draft is ready to go to the next stage for the working group adoptions. I think that is all from me today.
Okay, does anybody have any reason why we shouldn't do a call for adoption at this time? Otherwise, the chairs will issue one within the next short time. All right, that sounds good. We'll try to get that. We'll do a call for adoption soon and
Thank
see if
you.
we can get consensus on the list. Thank you.
Thank you.
Okay, Tim, do you want slide control or do you want me to do it?
You can do it if that's okay. It's
Sure.
easier. Yeah, thank you. So thank you for your time, everybody. I just want to present a short slide set on the RTP payload format for the JPEG XS video codec. It's also an ISO standard, so ISO IEC 21122. Yes, next slide, please. So currently today we already have an RFC for an RTP payload for embedding video frames and transporting them over the internet or over networks. It's a very important RFC, so it forms a basis via SMPTE ST2110-22 to do constant bitrate compressed video networks. And this RTP payload is actually used in many other industry consortiums or alliances like the AMWA with their NMOS specification, also by the Video Services Forum, I think it's called the VSF with TRO8. They have a specification for transport of JPXS. And then there's also IPMX, and it's used a lot in broadcast and Pro AV by companies like the ones I listed here. I even forgot to include my own company. The company I work for is Intupix, and also, for example, MediaLinks. So I forgot two important companies in this list, but okay, I don't think it's so important. Now, next slide, please. The problem currently today with the RTP payload is it works well, but it was written when JPEG XS second edition was enforced. It was actually written during the development of the first edition even. But today, JPEG XS is at its third edition. The most important parts of the standard were published in 2024, in around December, I think. And most notably, the third edition adds a new profile or a new coding mode, which we called the temporal differential coding mode. It's kind of interframe decorrelation technique. It's similar to what the real video codecs like H.264 and H.265, for example, do. But in this case, it's deterministic and it does not have any motion compensation or complex search space. So it remains a low latency temporal differential mode. And so the issue that we have currently is that the current RFC, so 9134, it actually refers to one of the internal marker codes. It's called the SLH marker, which is a 16-bit code in the XS code streams. It's defined in part 1 of the standard to mark the beginning of slices. A slice represents around 16 lines of coded information. Now, the TDC profile, it unfortunately uses a new 16-bit code called the SLI marker. And this one points to temporal differential slices. So for the RFC, the difference between the SLH and SLI is very minor. In fact, for the RFC, it doesn't really matter. It's just a 16-bit code that puts a boundary inside the code stream. And it's actually only used for the slice packetization mode. Now, TDC also introduces a new concept called the FBB level. So this signals the bandwidth of the frame buffer that is used for doing temporal differential decorrelation. And this one needs a new dedicated parameter for FBB, similar to what we already have in the RTP payload with profile level and SUT level. And then the two last bullets. So when the RFC 9134 was published and companies started to implement it, we received some feedback about some ambiguity regarding interlace video signals. And so we continuously try to explain what the intent of the RFC was, but at some point it was not clear and it was ambiguous. And so we would like to also address this. And there was also an erratum. So it's erratum 6752 for this RFC. So we would like to also implement this. Next slide, please. And so what I did is I started together with the original authors of the RFC 9134. We created a new draft to actually address all the issues and add functionality support for the TDC coding mode of JPXS. More in particular, make use of the SLI marker and at the FBB level parameter. And in the same time, we integrated the erratum and we clarified the text regarding the interlace video signals. And while working at it, I think I tried to do many minor text improvements to make the text more clear or more easy to understand. Important is that the new RFC or the new draft is actually 100%, I think, backward compatible. I think that's the correct direction. I don't know exactly, maybe it's forward or backward. I always mix them up. But in essence, the existing senders, so that implement RFC 9134, they will remain compliant with the new internet draft. They are compliant with the new draft, so they will not use any of the new features, and a new implementation can still receive them, the video stream. And the same for the other way, existing receivers will still work because they can see by reading the profile, they know whether they are working on the older profiles or the existing profiles or the new TDC profile. So it's compatible in both for senders and receivers. There's still some minor work to do on the draft, like something involving the slice definition, because there will be a new amendment made for the 3rd edition part 1. Actually, I'm one of the ISO editors of JPXS, so I know this will happen, but we try to make the new draft already compliant to what will come in the future. Next slide, please. And so my question here is if it's okay to consider this draft for working group adoption. That's it.
I think that certainly seems like a reasonable ask. This all seems like pretty minor work. So
yes.
It should be pretty easy to get through. If nobody has any objections, I think we can go to a call for adoption. We'll have to schedule, with chairs, we'll have to figure out how to schedule these various calls for adoption, though they're probably not hugely overlapping communities. So
yeah.
Probably
so sorry to interrupt. I didn't want to interrupt you. I'm on holiday during the next IETF meeting, so that's a little bit unfortunate timing-wise. But yeah.
I don't see this as something that feels like it needs a huge amount of face-to-face discussion anyway. It all seems pretty. So yeah, I think we can. I think it sounds like, unless anybody objects, the chairs will do a call for adoption on the list.
Thank you very much.
Yeah, sure. Thank you.
Okay.
All right, Jan, do you want to drive the slides, or do you want me to drive the control?
Yeah, please. You can contribute as this only few slides. Yeah.
Okay, sure.
Next slides. Yeah, just to recap the progress of the draft. So the draft was initiated in 2023 after the Green MPEG specification 2nd edition was finalized, and it was adopted as the WG draft. And after a couple of revisions, the latest draft is version 5, based on the feedback from the last WGLC. And it was uploaded in February this year. And during the development, there's over like 50 email exchanges, and received the questions, comments from experts, either from the email exchange or in the interim meetings. So really appreciate all those feedbacks to improve the draft quality. There's a call for adoption, and we get some support from Intel, Nokia, Ericsson, and those companies. And the last WGSC, we received the support for the co-authors, and there's no objections. So yeah, that's the status of the draft. Next slide, please. So in last meeting, I think there's interesting how whether this can be implemented or it has been implemented. So I list a number of examples, like first for the resolution change and the frame rate change on the fly. There's public available API from the NVIDIA Video SDK. There's API to enable such functionalities. And for the WRPC, that is open source project for the real-time video communication, there's also API to support this kind of features. So I think it's feasible to implement it in the established video codecs. And I also found that Microsoft actually has its own proprietary real-time transport protocol extension that has kind of exactly same design as what we propose. It uses RTCP to feed feedback message to trigger the encoder to change either the picture resolution or the frame rate or even the bill rate. So, but that is more like proprietary solutions. It uses the protocol extension to enable it, while we propose the feedback messages. And for the RFC 5104, there is a temporal spatial trade-off request and notification. It also kind of same approach to allow the receiver to request certain temporal resolution or spatial resolution changes from the sender side. So I think hopefully this answers the question that it can be implemented, and it's already been implemented. So yeah, that's this slide. Any questions on this one? If not, next slide, please. Yeah, here is a number of reference papers that our co-authors did some tests and show some benefit of this kind of approach. The approach originally is mainly targeting the energy saving. So from this figure, we can see like for HD resolution, based on the resolution change, it can save up to 20% energy saving without significant visual quality reduction. And this data is for HD. I expect like high savings for even like UHD, like 4K resolution video. So here gives some, provide some beneficial of these approaches. Yeah, the details can be found on those papers. So I think that's the update on this draft. And since the draft has been like started for quite a while, so yeah, I expect to see from the group what's the next step for this one.
So I think our main concerns, it's gotten good review from the MPEG side of things. I feel like I'm a little bit uncertain about the review from the RTP side of things. What I'd really like to get is some volunteers for review from people who know more about the RTP side of things before we go to publication request. So I'm going to ask here, people, yeah, just that would give us more confidence that yes, this is ready. I mean, I can certainly do one myself, but more. Eric, do you?
Yeah, I mean, I could help review because I don't feel like the questions I had on the email thread hasn't really been answered by this in terms of both, most importantly, what are the intended use cases? Like, is it to request a resolution that fits to the viewport of the user at the current time, or is it to do things like adapt down the video bitrate if you have CPU or network overload or something like that, and needs to request something lower that's not visible in like bandwidth estimates or other current available feedback mechanisms?
Yeah, I think the the original target is for energy saving. So, like for example, the device battery is lower, so the end user can request to reduce the resolution, and that will significantly reduce the energy saving. And the more, I think, broader use case is for the network bandwidth fluctuation. When the bandwidth is lower, I think that is already being deployed broadly. Like when the bandwidth is really low, the resolution, smaller resolution can fit that bandwidth, and it has been proved it's and one of the approaches to handle that case. The viewport part, I don't see the viewport, because for the viewport streaming, what you request is already the viewport. It's not like the entire videos and you reduce to the viewport. You just request the viewport directly.
Right. So that is part of it. That's sort of one of my questions. The other type of adaptation you mentioned to bandwidth, that's already widely done. Like the server already has the bandwidth estimate, and it can adapt based on that. But it doesn't know the decoder pressure on the remote side. So that's where I thought this was used for.
Yeah, I think bandwidth adaptation can be done on the sender side or encoder side. It detects the bandwidth. It does not need like RTCP from the end user to tell the encoder whether the bandwidth is high or lower. So this is more targeted to the device, like capability device properties, whether the device is need to reduce the resolution for some certain purpose. Yeah.
Right. Yeah, my other question had to do, I think it's been mentioned before, but is there any way we could have a clear definition of how the frame rate is actually stored, how to interpret the bits in the message? Because right now it just points to an ISO standard that's behind the paywall.
Yeah, I think the resolution has some clear definition, but frame rate, there's no such, even on the codecs level, there's no even no signal to signal that. Just the bandwidth is how the bit rate is allocated different based on the different bit rate or frame rate. Yeah, for that part. Yeah.
So I'm talking about specifically, like, say you want to request the frame rate of 25. How is 25 represented in those 16 bits or whatever it is? Is it like a Golomb or something, or is it a fixed point integer? What are you using? That's what I'm sort of concerned about, because that's not clear at all from the current draft.
So that signal is just explicitly signal what's the preferred frame rate. Because reducing the frame rate can map to the energy saving. That's obvious.
Yes. I'm not talking about the usage of it. I'm talking about you're requesting the frame rate, or say 29.97, since that's a common thing. How is that represented in the bits in the message? Like, how is it encoded?
Currently, I think it only supported integer frame rate, but you prefer to also support the fraction number.
Okay, if it's an integer, we are just requested it says that it is an integer, because that's not clear. Okay, that's all from my side for now. Thanks.
Okay, thank you.
Yeah, so it's a bit unfortunate that this draft has stalled a bit, but it was mainly due to the low number of responses in the working group last call for this document, which didn't really for us show that there's a clear consensus that this is yet ready for publishing. Your presentation did help a bit in showing where this and similar techniques is currently used. For example, the Microsoft example is quite helpful in showing that other parts of the industry are already doing something similar, even if not exactly following what this draft does. For us, it would also be really helpful not only showing that this is theoretically possible to implement, but also I'm wondering if you can point to explicit implementations that are already doing this nowadays, or are planning on doing this, and whatever this draft implements. I think that would be really helpful to showcase to the working group, seeing that this is done already, and then we can see, okay, seems to be a fairly reasonable approach, and that would bring us closer to a publication.
And in particular, if an implementer has used this draft as an implementation and said, yes, this draft gave me everything I needed to do my implementation without needing to ask questions or figure out ambiguities, that's always very useful.
Yeah, I think I just give some example, like in Coda side, it has the public available API you can call. And on the RTP, RTCP side, even the web ITC has the source code. You just
I mean, yes, there are certainly lots of things that do similar things, but I mean, explicitly this exact thing would be, somebody's actually implemented this draft and said, yes, this does what I need. I mean, it shouldn't be a very complicated if you have an implementation, and if people are planning to do it. I know there's sort of a chicken and egg, but just sort of as a prototype, say, yes, this draft solves my problem is very helpful.
Yeah, then I think the paper already, like from the example here, like they have the device to detect the power measurement and give some results. It does solve the issue, like reduce the power consumptions by dynamically reduce the picture size.
Okay. Are you aware of any production deployments? Was this more of an experiment, a study, or was it like a production?
Definitely, like people can use Microsoft proprietary solution to do that, but our customer really prefer like more general standardized way to do it. I think from my company side, definitely we are interested in more like standard specific solutions for this.
Yeah. Yeah.
많이 안 나잖아. 공부 식단 호흡을 주중에 치는 건 좀. 또못 내킨다면 또 여기서 올릴 거라. 그러니까.
Young Kwang, your audio is very hard to understand. I'm sorry.
이러면 별로 그렇게 열심히 골프를 치고 싶은 생각이.
Oh, Young Kwang, your sound is on and off.
아이 좀 세워놔면 또만 안 넘어. 그래도 달렸어. 빨리 갔어. 빨리 해, 빨리. 100% 채워.
Could you say it again?
고장 난 거야? 아니면은 이제 고쳐진 거야?
I'm not sure. Maybe he was unmuted.
왼쪽이면 확실하게 골프 때문에.
I'm not sure if that was unmuted on accident. I just removed audio. If that was incorrect, please unmute yourself again. But I'll clear the queue for Stefan, please go ahead.
Young is the WG3 chair that the Green Ampere was draft published. So yeah, I think his comment may
I think he had a comment at the first time, but after that he forgot to turn off the mic, so you can check to the question to him again.
Okay.
Stefan?
So I want to question this input from Marius a little bit here. I don't think it is a prerequisite for any RTP payload format to show working implementations or deployed implementations. I would not want to see that as a precedence, generally speaking. And the reason is that for a lot of this RTP-ish stuff, the deployment will happen only once the suite of standards is more or less complete, right? And things like payload formats shouldn't be the gateway to hold up a whole industry. So I would suggest that that we shouldn't establish precedents even for something like this. That working implementation becomes a prerequisite for going to working group last call or for going to IETF last call. Thank you.
One other question, Stefan. Is this also something where you can provide is this the document? Is this one of the things you're the liaison for?
Yeah, the usual mechanism there applies for all the impact documents. For those who want to review this the specification and think they need input to need access to the ISO specifications, they can contact me, and I can make those available in an legal way. That's what we have used in the past, and that we can use here also. Thank you.
Okay, Gary.
Okay, thank you. Oh, yeah.
Yeah, I was just going to comment on the experience we had with the spec. I guess in many IETF documents, we expect a PS to be implemented and somehow demonstrated. That's one way of showing that the spec is complete and has received enough views so that we know that this is actually a document that people need. I mean, there might be other ways to do that by people doing active reviews and looking at it with an intention to implement and actually providing comments on the list. So I think there are a number of different ways we can figure that something is very well specified, needed, and that this is the appropriate time to publish. So let's try and keep this discussion going and see if we can get that review onto this particular draft.
Great, thank you. All right, and as said, anybody, particularly people with more expertise on the RTP side of the fence, I would certainly like to get more reviews. So please, please do so. All right. That said, I think we can move on to region of interest. Srinivas, do you want to control the slides, or do you want me to control the slides?
Thank you, Jonathan. You can control the slides.
Okay, sure.
Yeah, thank you. Can you move to the next slide? So basically, the previous individual draft on the viewport and ROI dependent delivery of the visual volumetric media got AVTCORE working group adoption, and the new working group draft version 00 was published in last month. And for the earlier draft, we received comments from IANA mailing list that the new additions in the IANA considerations clause needs to specify the names listed in the IANA website for SDP parameters and the RTP parameters. So I addressed the comments received from IANA in the IANA considerations clause in 8. So I just give a little background on the immersive media and the motivation behind this partial delivery of the immersive media that was presented in this draft. Traditionally, the multimedia applications such as video are pretty popular, but nowadays the requirements of emerging media technologies such as XR, VR for immersive experiences is growing a lot, and also for 5G advanced and 6G use cases, we have been dealing with several XR use cases, which involves the AR conferencing, shared AR conferencing experiences, and streaming the volumetric videos to glass type of MR devices and all. So this kind of streaming of immersive media experience, of immersive media for immersive experiences is gaining a lot of traction. So the working group 7, basically the MPEG working group 7 has developed a visual volumetric media compression standard, a video-based compression standard for dynamic and dense point clouds, and a geometry-based compression standard for static and sparse point clouds. So the RTP payload format for the real-time delivery of the V3C media was proposed in the AVTCORE working group and is currently in the final stages of the adoption. So based on that draft, we can basically transport the V3C content over RTP. And now, because the amount of content present in this volumetric media has enormously high. So obviously, when users are interested in requesting the content based on their viewport or regions of interest, so that was lacking in the that kind of approach is lacking, and this draft basically provides details on how a region of interest dependent delivery or a viewport dependent delivery can be worked for V3C media. Can you go to the next slide, please? Next slide, please. So obviously, because partial access of this V3C media and streaming of this partial V3C media is required for limiting the bandwidth. So we proposed actually 3 different mechanisms. One is like RTCP feedback messages, where if you want a specific region of interest, a static region of interest, or an arbitrary spatial region of interest, or it can be a viewport-based feedback message, a request for a V3C media. So when an RTCP feedback message with such a request goes to the sending entity can transfer that particular 3D region or that arbitrary spatial region or content related to that viewport. The requested viewport can be done. So when transferring it, it need not be exactly matching with the exact request. So to avoid such kind of, to avoid the ambiguities of what has been sent, so an RTP header extension is proposed to report like what kind of 3D, like which 3D region, spatial region has been transmitted. So along with the V3C media of a specific 3D spatial region, we provide this RTP header extension that informs like what kind of what 3D regions have been transmitted. And in case if it's a dynamic 3D region, we can also inform that. So there are cases where the 3D spatial regions are changing over time. And in that case, obviously, we can even report those dynamic 3D spatial regions in the RTP header extension message. So if the RTCP and RTP header extensions are provided, then we can also provide the SDP signaling such that such kind of support is supported by the RTP sender and are also supported by the RTP receiver. So there will be a signaling for informing the static 3D regions and what kind of RTCP feedback messages are supported and what kind of RTP header extensions are supported can also be present, can be signaled in the SDP signaling. Thank you. Can you go to the next slide, please? So in the previous draft, we got the working group adoption, and then I actually provided a GitHub, uploaded the thing in the GitHub repository. A repository was created and uploaded there, and we welcome any suggestions and feedback on this draft. Thank you.
Okay, so what would you say is the status of this? Is it still being worked on, or is it?
So there were a couple of things. I mean, like one specific thing I identified, there was a slight misalignment with the MPEG final specification on the MPEG-I Part 5 or MPEG 23090 Part 5 specification and the viewport, and I'm gonna change and do an update on that in a week's time. But apart from that, I feel like it's in a good shape, but I would basically request someone to review the draft and see. It will be good from the RTP perspective and the SDP perspective. It will be good to have a review of the draft.
Okay. And what is there implementations? Are anybody starting to implement this yet?
Currently, we don't have any implementations, but similar implementations for 360-degree were available. I can provide the details probably a little later, but yeah, I mean, currently the V3C volumetric media is I mean, it's standard-wise, it was existing, but implementations-wise, it was completely new. But for this partial access, we don't have currently any implementation as of now.
Okay. Right. So I encourage anybody who's interested in this, please review and give feedback.
Yeah, that'd be great for us.
All right, and with that, I think we are done. So I think I can review. I think for SDP offer answer and S-frame, we think we probably should organize some side meetings in Madrid. For VDMC and JPEG XS, we're going to do calls for adoption. We're trying to encourage more review for temporal spatial resolution, and we encourage people to review region of interest. And so have I missed anything?
Not sure. Did you say last call for ROC as well?
Oh, I didn't say that, but no, yeah, we did say we would do the last call.
Okay.
I think we're ready for the last call for ROC. Okay.
Yeah, perfect.
Sounds
Then
good.
that's my list as well.
Great. All right. Anybody have any other topics or anything? Otherwise, we can call it. And thank you all for attending.
And thank you for sharing.
Thank you. Yeah.
Thank you. Bye.
Bye-bye.